Hello. Today we're going to start looking at dilations on the coordinate plane. So the objective is students will be able to describe the effect of dilation on two-dimensional figures using coordinates. Some of the vocabulary that you'll have to deal with today is coordinate pair, x-coordinate, y-coordinate, dilation, scale factor, image, and pre-image. And so we're going to start to merge the concept of dilation on top of some of the results and kind of come up with some more generalized rules about dilation when it comes to a coordinate plane. And so as you're looking at it, question number 1 says point -8, 5 is dilated from the origin by a scale factor of 1/2. What are the coordinates of B prime? And so if you're looking at this and you count -1, -2, -3, -4, -5, -6, -7, -8, 1, 2, 3, 4, 5. That would be the point B. And for the moment, we've got this idea that we can use a compass or even a ruler. And if I measure between point B and the origin, I realize that this is approximately 3 8/10 of centimeters. And so if I take half of that, I'm looking at 1.9 centimeters. And so then you start thinking about, well, what's the relationship between the coordinate I just put down on the paper, which is B prime, and the original, which is B. And so this is -8, 5. I use this measuring technique of dilating along the line between B and the origin, which is our center point O. And it looks to me like the coordinates are 4, -4, and 2.5. And so I begin to ask myself, what's the relationship between -8 and -4, and +5 and +2.5? So if you're just filling this out, it's -4, 2.5. Or maybe even better listed is 5.5. And so again, you're kind of comparing 5 and 1/2 and 2.5 or 5/2, -8 and 4. My next coordinate, point E, is -2, -5. It's point E. And I'm going to dilate this by a scale factor of 3/2. So if I look at that, again, you can measure, and this is 2.2 centimeters long. Take out your calculator, multiply that by 3/2, and you'll get 3.3. So there is E prime. And again, I begin to think about this in terms of what's the relationship between -2 and -5 and -3 and -7.5. How do these coordinates relate to themselves? And I'm starting to think that, like, if I took -2 and multiplied it by 3/2, that would give me -3. If I multiplied -5 by 3/2, that would give me 15/2, which is the same as 7.5. And maybe we'll go through just one more. And it says here point C is 6, -2. So 6, 1, 2, 3, 4, 5, 6, and -2. And that's point C. Take out my ruler, measure from the origin out. It looks to be just about 2.6, so 3/4 of that. Gives me a spot right there. And so, sorry. right here. So not that spot, that spot. 3/4 of 2.6 should be right around 1.9. And so if I'm looking at this, that should be 4.5 and -3/2. And so I start wondering, is that connected back to this? And so 6 times 3/4 and -2 times 3/4. Well, that would give me, if I reduce this, 18/4, which is really 9/2. So that's how I got the 4.5. And this is -3/4, which would give me -6/4, which would be -3/2. That's how I got the 1.5. And so I've sort of generated this idea that if I multiply both coordinates by the scale factor, I can get the new coordinates. So A prime is the result of 7 times 6, comma, 9 times 6. And so A prime is 42, 54. Oh, sorry, 42 and 54. The next one, again, this would be off the grid, so I can't really use that anymore. And then 0 times 4, comma, 11 times 4 would give me D prime, and so D prime is 0, comma, 44. Again, completely off the chart. So that's the importance of understanding this relationship as you're going through it. So what can we say about the relationship between the coordinates of the pre-image, the coordinates of the image, and the scale factor? And so the image is the product of each coordinate and the scale factor. So x prime, y prime is equal to rx and ry. Okay, you might want to pause this at the moment and get ready to summarize. Okay, so we have a little bit more complicated things in the form of the triangle. And so as we're looking at this, I notice they give me a scale factor of 12. Well, I know if I multiply this by 12, it's going to be completely off the grid. So I really have to rely on the fact that we just determined. And let me look at A is -2, 2. Just get the coordinates down. C is 6, 1. B is -3, -3. And so if I'm trying to figure out the transformation, it'd be A is 2, 2. B is -3, -3. C is 6, comma 1. And so C prime would be 72 and 12. B prime would be 36, negative, and -36. And A prime is -24, 24. Real quick, got these from multiplying each of these by my scale factor of r. And so that's the importance of understanding. The next one only has a scale factor of 2/3. And so there's a few nice results from this, and we'll first start off by identifying each of the points. Okay, I might write them down over here so I can work with them as I'm making my calculations. And so D prime, E prime, F prime, and G prime. And so each of these I'm supposed to multiply by 2/3. So -6 times 2/3, -4, 3 times 2/3 gives me +2. E, -8 thirds, because I get 4 times 2 is -8, divided by 3, and then this is -2. 10 thirds, -4 thirds, -2, and 2. All right, so the next thing I actually kind of want to do with you guys is plot these. So -4, 2, -8 thirds, -2. So 8 thirds is just before -3. And then 10 thirds and -4 thirds. So that's kind of in no man's land, but 10 thirds is 3 1/3. -4 thirds is just beneath 1, so it's just about there. And finally, -2, 2. I draw this quadrilateral for you guys, and what I really want you to notice is actually a result of some of the recent videos. In that if I'm supposed to dilate an object, what happens to the angle measure? What happens to lines that are parallel? Well, in fact, this top line is parallel to that, since they're in proportion. And you can kind of just work your way around the object and know that they're parallel. And you can see it pretty easily once you have a grid, because you can count boxes. And so I wanted to make sure you understood that connection from some of the recent work. Okay. Next says triangle ABC is shown on the coordinate plane. The triangle is dilated from the origin, so that's really a key fact. You've got to make sure you understand what the point of dilation is from, and your scale factor now is 5/4. You want to identify your points. So this is -14, 8. B is -12, -1. And C is -4, -1. And so use the space to get A, B, C listed out. So -14, -8. B is -12, -1. And C is -4, -1. And I'm multiplying this by 5/4. And so A prime, I'll get -35 halves, comma, -10. B prime, I'll get -15, comma, 5/4. And C prime, -5, -5/4. I go around and I plot these. So there's B prime, C prime, and 35 halves, 17 halves, and -10. There's A prime. You want to draw this triangle out, and then definitely check to make sure your lines are parallel. There would be one indicator that you've either done something correct or incorrect, depending on whether they do maintain parallel lines or not. Okay, and so it does appear that these have the exact same slope since they're horizontal. These are identical, and finally this long side. And so we've maintained the theorem that we've learned recently about if we have a dilation, the resultant lines from the point, that third side of the triangle would be parallel and in proportion still. And if we measured this, that would be the case. Final problem. So the triangle ABC has coordinates 6, 1, 12, 4, and negative 6, 2. If it's dilated from the origin by a scale factor of 1/2, identify the coordinates of the dilated triangle of ABC. So 1/2 of 6 is 3. 1/2 of 1 is 1/2. B prime would be 6, 2, and C prime would be negative 3, 1. And each of these was found by multiplying each coordinate by R. Okay, so you want to pause, write your lesson summary down. Thank you for your time.